The second part in this experiment is about B2Spice. So we have to simulate the circuit using B2Spice. So here it is, we have the same circuit, and we have voltmeter 1 connected to the source, voltmeter 2 connected across the 4.7 to measure VO, and we have a meter connected in the branch in series with the resistor. So let us see how can we do it using B2Spice. So here is the circuit. So what we need to do is just connect it like this, like what we did before, and make sure that we have the right values. 1K, this 1K, this is a 2.2K, so this is a 2.2K. 6.8, 2.2, 4.7, 10, 7.8, and the voltage is variable, as I mentioned before. So let us make the voltage 2.5 volt and then run the simulation and look at the result. Before we do that, remember that we have to go to setup and make sure that this op is required, is enabled to know the voltages here at this node here. Of course, in this case, we don't need this. In this example, we don't need the voltages, so we don't care too much about them. But let us see how the result look like. So now you see the voltage is 2.5. Makes sense, of course. This is exactly the same like the source. The voltage at the output is 100. No, it is 934 millivolt. So when you fill the table, this will be the numbers. Let us put the numbers here. So these are the numbers. So this one is 2.5, of course, volt. The voltmeter reading number 1 is 934. Okay, point, because it is, this is, if we want to do it in volt, we have to copy it in volt. So here's the reading of the number 1. Number 2 is 934 millivolt, which is 0.934. Okay, what about the current? The current is 198 micro, which is supposed to be in milliamperes. Supposed to be milliampere. Sorry. So we have to change this one. This will be 100 or 0.19875 milliampere. If I want to divide the voltage over the resistance to fill the fourth column, that will be 0.934 divided by 4.7K, then this will give us 0.1987. You see, this is the number here. Okay, so 0.1987, 0.1987. I don't know what was before or after 7. It was 23. Okay, 23. So as you see here, the two numbers are very close to each other. Then after that, we need to change the voltage, okay, to make it, instead of 2.5, you make it, no, not this one here. And instead of 2.5, make it 5 volt and fill the second row. So now run the simulation again. So you see this is 5 volt now, and the voltage here, the voltage is 1.87. So this voltage is 1.87, which is double this value, double, because we multiply the voltage by 2. Okay, this one is 5 volt, this one is 1.87. What about the current? See the current. The current is 397 micro, which is 0.397. 0.397 milliampere. Okay, Now if we want to calculate the current using Ohm's law, so it will be 1.87 divided by 4.7K, which is 0.39787. 0.39787. Okay, so here it is, 0.39787, which is also close to this one. Even if this one is 0.398 and this one is 0.397, there's no big difference between them, and so on, and so on. So this is what you need to do for this part. Okay, you continue, make it 7.5, make it 10, and so on. So is there any difference between reading the voltmeter reading and the voltage source? No, of course. This one is exactly the same. Of course, in B2 Spice, there's no error, there's no error. And did you almost have the same answers between the fourth column and the ammeter reading? Yes, they are very close to each other, or almost the same. When you change the voltage from 2.5 to 7.5 to 5 to 7.5 to 10, what do you notice? That you multiply the voltage by the same number. So you see here from 2.5 to 5, you multiply by 2. Let us multiply this by 2 to check. Multiply, for example, the reading 0.934 multiplied by 2. It will be very close to this 1.68, 1.6, 1.87, 1.868. They are very close to each other. And if you multiply, for example, or multiply the number here by 2, 0.19875 multiplied by 2, and see the answer is 0.3975. It's very close to this. Okay, so here when you multiply the voltage by 2.5 to make it 5, you multiply everything by 2. If you multiply by 3, you multiply everything by 3. If you multiply by 4, and so on. Okay, so this is the last slide in this experiment. And this experiment, the exercise is embedded in the lab work. So you have to do the same lab work as exercise. Okay, I hope you enjoy this experiment and see you in the next experiment. Have a nice day.